Hello everyone, welcome to my presentation. My name is Luna. Today my presentation topic is functional and technical rationales for incorporating MLOps. Here's the table of contents. There are three parts in this presentation. The first part includes some background knowledge regarding machine learning, its design considerations, and what is machine learning operations or MLOps. The second part includes drawbacks of MLOps, building blocks, and advantages of MLOps. The third part of the presentation focuses more on the analysis and critical reflection on the topic, which includes main design considerations, concerns, and limitations regarding MLOps. I would like to start by giving some background knowledge. What is machine learning, abbreviated as ML? Different institutions give slightly different answers, but they have generally the same idea. According to IBM, ML or machine learning is a part of artificial intelligence that allows computers to become more accurate at predicting outcomes without being explicitly programmed. Machine learning is a form of artificial intelligence that teaches computers to think in a similar way to how humans do, learning and improving upon past experiences. It works by exploring data and identifying patterns and involves minimal human intervention. Um, Overall, machine learning is an important component of the growing field of data science. Through the use of statistical methods, algorithms are trained to make classifications or predictions. Um, when designing and choosing a model, the quality of the model's results is a fundamental factor to take into account. So the first main design consideration associated with machine learning systems is performance. So you want to prioritize algorithms that maximize that performance. Depending on the problem, different metrics could be used to analyze the results of the model. For example, some of the most popular metrics include accuracy and precision. But do know that not every metric works in every situation. For example, accuracy is not appropriate when working with imbalanced datasets. The second one is explainability. In many situations, explaining the results of a model is paramount. Algorithms works like black boxes. The team needs to make sure the results are able to be explained. Understanding how easy it is to interpret the results of each model is important before picking a good candidate. The next main design considerations is complexity. So, a complex model can find more interesting patterns in the data, but at the same time, it will be harder to maintain and explain. So, it's sort of like the trade off. Overall, more complexity can lead to better performance, but also larger costs. Complexity is inversely proportional to explainability. The more complex a model is, the harder it will be explain its results. And putting explainability aside, the cost of building and maintaining a model is a crucial factor for a successful project. A complex setup will have an increasing impact during the entire life cycle of a model. The fourth design consideration is ethical consideration. Along with potential benefits brought by machine learning applications, it also raises a number of ethical concerns. So, a machine learning design needs to include ethical evaluations, especially for a diverse group of stakeholders. We want to make the AI responsible. Some examples of how to make AI responsible include intensive user research, or performing ethical evaluations starting with a conceptual model of the pipeline of the conception, development, and implementation. What is machine learning operations, abbreviated as MLOps? Um, Generally, people see MLOps a lot. First of all, it stands for machine learning operations, and it is the AI lifecycle for IT production. MLOps is modeled on the existing disciplines of DevOps. MLOps adds to the team the data scientists who curate datasets and build AI models that analyze them. It also includes machine learning engineers who run those datasets through the models in disciplined, automated ways. MLOps is a process that enables data scientists and IT or engineering teams to collaborate and increase the pace of model development. Alongside continuous integration and deployment with proper monitoring, validation, and governance of the machine learning models. Again, different institutions have slightly different definitions of MLOps. For example, I put a screenshot of how Microsoft defines MLOps. MLOps is based on DevOps principles and practices that increase the efficiency of workflows. Examples include continuous integration, delivery, and deployment. Overall, in my opinion, I think MLOps is more of a management practice. It is a process that you engage in at a depth that depends on your specific needs. MLOps fosters communications and collaboration between operations professionals and data scientists. So previous approaches of machine learning project flow look like this. There's a data scientist who needs to solve some business problems that can provide some impact. The data scientist investigates the problem, gets the data, does data analysis, cleans the data, experiments with different kinds of models, and then saves the best model and the data used for the creation of that model. Now the model needs to be served so that it can be consumed by the business applications. There are some drawbacks with this kind of approaches. First of all, due to its waterfall nature, it has a fixed plan. The plan is non adaptable and is developed at the very beginning, so it is unable to accommodate continuous feedbacks. Secondly, the previous approach is sequential. Project is divided into successive phases, which are not revisited once completed. The third drawback is that it feels slow. Only towards the end of the project one knows if requirements have been met. This will greatly increase the cost if anything goes wrong. The last drawback is the participation of users is not required. Users' needs and priorities are not gathered throughout the development phase. Main building blocks of MLOps. As I previously mentioned, MLOps is modeled on DevOps. If you look at the figure, MLOps is just by adding ML into or onto DevOps, which are development plus operation. So as a whole, MLOps adds the machine learning component of the team, which are the data scientists and machine learning engineers to the team. When an algorithm is ready to be launched, MLOps is practiced between data scientists, DevOps, and machine learning engineers to transition the algorithm to production systems. A majority of enterprises deploy MLOps principles across the following: exploratory data analysis or EDA, data prep and feature engineering, model training and tuning, model review and governance, model inference and serving, model monitoring, and automated model retraining. How does MLOps address shortcomings that were mentioned in previous MLOps approaches? Firstly, MLOps encompasses that experimentation, iteration, and continuous improvement of the machine learning life cycle. Therefore, MLOps boosts collaboration between experts in different teams. It facilitates communication between different experts, more specifically between data scientists who build machine learning models and operation professionals who put these models into production. Overall, as a result, MLOps allow data teams to achieve faster model development, deliver higher quality machine learning models, and faster deployment and production. MLOps also enables vast scalability and management where thousands of models can be overseen, controlled, managed, and monitored for continuous integration, continuous delivery, and continuous deployment. Um, Specifically, I think MLOps provides a reproducibility of ML pipelines as well. Secondly, MLOps aims in risk reduction by enabling greater transparency and faster response to drift check. This enables or ensures greater compliance with an organization's policies. Finally, the level of automation of the data, machine learning model, and code pipeline determines the maturity of the machine learning process. With increased maturity, the velocity for the training of new models is also increased. The objective of an machine learning operations team is to automate the deployment of machine learning models into the core software system or as service component. This means automating the complete ML workflow steps without any manual intervention. The automation, there are three levels of automation for MLOps. The first level is manual process. This is a typical data science process, which is performed at the beginning of implementing machine learning. This level has an experimental and iterative nature. Every step in each pipeline, such as data preparation and validation, model training and testing, are executed manually. The common way to process is to use rapid application development tools such as Jupyter Notebooks. The second level of automation is machine learning pipeline automation. This level of automation includes the execution of model training automatically. Here, the continuous training of the model is introduced. Whenever new data is available, the process of model retraining is triggered. This level of automation also includes data and model validation steps. The third level of automation is CI/CD or continuous integration and continuous delivery pipeline automation. In the final stage, this CI/CD system is introduced to perform fast and reliable machine learning model deployment in production. The core difference from the previous level of automation is that we now automatically build, test, and deploy the data machine learning model and the machine learning training pipeline components. Main advantages of MLOps. The first one is definitely improved communication between different experts in different teams. So MLOps, from its components, we can see that it definitely facilitates communication between different experts, as mentioned, more specifically between data scientists who build machine learning models and operation professionals who put these models into production. The second advantages of MLOps is reliability. Incorporating CI/CD practices allows for the ability to not only deploy quickly, but with increased quality and consistency. The third advantages of MLOps as I introduced are automation or automated model building. The objective of MLOps team is to automate the deployment of machine learning models into the core software system or as a service component. After data scientists and system integrators collected and cleaned up data, they had to manually create, validate, and deploy the model. These actions could mislead to errors and to lead to overrun in operational costs. So, to truly create efficiency in operational tasks, training and deployment pipelines need to be automated. Automation can benefit data scientists to focus on what they do best, extracting business focused insights, research, and looking for innovation and revolutionary techniques to solve AI issues. The third or last main advantages is auditability. So versioning our inputs and outputs from data science experiments to source data and train model means that we can demonstrate exactly how the model was built and where it was deployed. Um, Main technical design considerations associated with MLOps. So the first one is ensuring compatibility with data science environments. So thinking about when building with Lego blocks, the main consideration is whether the pieces you're using fit together. The same is true in MLOps. When building a data processing model, all parts must fit together and work together seamlessly for the best possible results. For example, if an organization runs heavily in a public cloud such as AWS or Azure, it will likely require MLOps tools that can run in this environment while working together with other tools such as MLflow or other cross-platform tools. Just like you wouldn't lock two data scientists in separate rooms with no way to communicate, you don't want MLOps tools unable to talk to each other. Um, and that also helps to build efficient pipelines. So it is always critical to use the same data pre-processing libraries in every pipeline to prevent multiple compatibility errors. The next main technical design considerations is machine learning security. So machine learning security is important because machine learning systems often contain confidential information or offer a competitive advantage to an organization that they wouldn't want competitors to have access to. Some organizations use machine learning for security reasons to detect security breaches in other systems, so that the safety of that machine learning model itself is crucial so that their security system is trusted to protect another system. Data security deals with securing the data, which means that there should be a minimum privacy policy that can help in the planning to limit user access. The data should be organized so that it should be clean and secured. Main concerns associated with human factors in the context of MLOps. The first one is ownership issues. So oftentimes all data is not available to single authority. Adding data owned by private companies such as banks form another layer of organizational complexity in this context. Operations related to data seems to be the most difficult to put into practice. In general, systems like data lakes can be used to integrate data from various sources, but if amounts of data are massive and in addition its owner want to protect it, this option is feasible only inside of one organization. Secondly, some data is not automatically shared, but is something that only the individuals can release in accordance to their wishes. It is not obvious which data is true and which is false, as individuals themselves provide some data and moreover, they can manipulate some data. The next one is model selection. Model was selected such that for given input, it produces a deterministic output. Overall, the decision is always made by the humans, and the AI only has a supporting role in the process. Therefore, the responsibility is carried by the humans, not the AI. Furthermore, in this unlikely event of the system malfunctioning and providing some answers that clearly are not feasible, um, so it depends on the humans who will be responsible to notice them and fix the situation. The last one is a handoff from data science scientists and software developers. So all teams need to come together from the onset to lay out clear expectations and testing practices for each team member and component involved. Here are some main limitations of MLOps and some possible mitigation. So one of the limitation is that um, the managed platforms are or could be inflexible and slow to change. They might provide 80% of the functionality we require, but it is often the case that when the missing 20% provides functionality that is mission critical for machine learning projects. The close design and architecture of the managed platforms makes it difficult to make even the most trivial changes. So, to compensate for this lack of flexibility, we often have to design custom, inefficient, and hard to maintain mechanisms that add technical debt to the project. The other limitation is that problems arise during retraining ML model. It is impossible to measure the accuracy and consistently evaluate the model. So after monitoring and tracking your model performance, the next step is retraining the machine learning model. The objective is to ensure that the quality of the model in production is up to date. However, even if the pipelines are perfect, there are many problems that are complicated or even make retraining impossible. From the point of view, the most important of them is the new data manipulation. When a model is deployed in production, we use new raw data to make the predictions and use them to extract the final results. However, when we are using supervised learning, we do not have at our disposal the corresponding labels. So it is impossible to measure the accuracy and constantly evaluate the model. It is possible to perceive the robustness of the model only by evaluating the final results, which isn't always an option. Here's my reference. Thank you very much for listening.